The Advanced Kinetics Analysis program calculates the initial velocity of a reaction based on absorbance or fluorescence time course data. By plotting the calculated initial velocity versus the substrate concentration, the maximum reaction rate or Vmax, Michaelis-Menten constant Km, and Hill coefficients can also be determined, as well as the enzyme activity and inhibition constant. Under Analysis in Spectrum Manager, select Kinetics Analysis. First, open your time course data to be analyzed by selecting File New or select the New icon in the menu toolbar. At least 5 sets of time course data are required to analyze the velocity parameters and inhibitors. You can open more than one JWS file at a time or all at once by selecting the first file, holding down the Shift key, and selecting the last file you wish to open. There are 3 analysis modes: enzymatic activity calculation, velocity parameters calculation, and enzyme activity table, which can be selected from the icons in the menu bar. The enzymatic activity mode can be used to calculate the initial velocity and enzyme activity. If the data files are in the same data view, select the desired time course data in the display column of the worksheet to show that time course data. To adjust the time range for a single time course measurement, select the display box next to the measurement of interest. The blue shaded region represents the time range for calculating the initial velocity. The initial velocity is determined from the slope of the curve at the beginning of the reaction and is depicted in units of absorbance per minute. By moving the shaded region, the red line can be made tangent to the curve and the initial velocity calculated. Click the blue shaded region and either drag that area around to specify the start and end times, or if the range needs to be shortened, select the edge of either the left or right of the shaded area until an arrow pops up and drag to the desired time frame. As the range is moved, the corresponding velocity will recalculate and is displayed in the table below the graph. If all the time course data is in the same view, the time range for each measurement can be adjusted by selecting the display checkbox next to the desired file. To select more than one, hold down the Shift key and select the data files. Once the time range has been set and the initial velocity is calculated, enter a factor to correctly determine the enzyme activity based off the time course data. The activity is the slope of the line, which is determined using the least squares method and is multiplied by a factor or reaction volume. If you would like to determine the specific activity, the units will differ and the factor needs to be adjusted accordingly. The difference column reports the difference in the absorbances of the calculating or blue shaded region. To determine the Michaelis-Menten parameters, select the Velocity Parameters Calculation icon in the menu bar or go to Settings, Analysis Mode, Velocity Parameters Calculation. First, set the units for the substrate concentration by going to Settings, Concentration Unit. Enter the units in the text box or make a selection from the list. Then click OK. Enter the substrate concentration in the S column of the worksheet by double-clicking the cell. Specify the calculation range of each time course measurement by either dragging the blue shaded region or entering the start and end values. Then either go to View Analysis Results or click the Analysis Results icon in the menu toolbar. Specify which plot used to determine the velocity parameters by selecting from the Calculation Method drop-down list. There are 5 available methods for calculating the velocity parameters: Michaelis-Menten, Lineweaver-Burke, Hofstee, Eadie, and Hill methods. While the Michaelis-Menten plot estimates the velocity parameters using nonlinear regression, the Lineweaver-Burke, Eadie, and Hofstee plots all linearize the data based off the Michaelis-Menten equation so that the Km and Vmax are determined from the slope and y-intercept. The Km is the concentration of the substrate when the enzyme reaches half Vmax. The smaller the Km, the better the binding efficiency, or larger the substrate's affinity for the enzyme. The Vmax and Km values are then displayed on the left-hand side of the screen along with the equation of the line, the slope, and the y-intercept depending on the calculation method chosen. If an inhibitor was used in the time course data measurements, the inhibitor constant can be calculated. Since the inhibitor constant calculation is based off the Vmax and Km values, these values must first be determined as described previously. Select Inhibitor Calculation from the Settings option in the menu toolbar. Select the checkbox for Calculate Inhibitor Constant. Choose an inhibitor type from the drop-down list and enter the concentration. Then enter the Vmax and Km values calculated from the velocity parameters analysis. You can also import the parameters from another view open in the kinetics analysis software by selecting the Browse Data, or import a previously saved kinetics data file by clicking Browse File. If the Vmax and Km were determined using another calculation method, the analysis will still be performed. If the parameters have been manually entered, click Apply, and then click OK to perform the inhibitor analysis. The inhibitor constant Ki and the type is displayed on the bottom left side of the screen. The plot used to determine the inhibitor constant is overlaid in blue in the analysis graph window. The Enzyme Activity Table tab displays the activity calculated from the difference in the absorbances at varying times multiplied by a factor. The pitch or data interval is automatically set based on the start and end values set for the time course data. However, the Enzymatic Activity Calculation tab is more commonly used to determine the sample's activity.